The steps for solving radical equations. Isolate the radical. Isolate the radical means get the radical on one side completely by itself. Nothing multiplied in front of it, nothing added or subtracted behind it. The thing that you need to remember is that when we are solving equations, we are using PEMDAS backwards. So we actually need to deal with any subtraction or addition first, then any multiplication or division, then we'll deal with the radical and so on and so on. Step 2, once the radical is isolated, take the power of the index to each side. So again, if it's a square root, if it's an index of 2, you'd square both sides. If it's a third root, you'd cube both sides, and so on, and then finish solving the equation. So number 1, what do you think we're going to do in number 1? Subtract 6. Okay, now notice that this is the third root. It's not 3 times the square root, it's the third root. So, should we divide by 3? Cube it. This is a cube root. To undo a cube, to undo a cube root, you use a cube. So we are going to raise both sides to whatever the index of the radical is. So since it's a third root, we're going to raise both sides of the equation to the third. 6 cubed. What is 6 cubed? Grab your calculator. 6 cubed. And on the left side, the cube root of x to the third is x. So our solution is x equals 216. Now, the directions say check for extraneous solutions. I'm going to give you a huge hint. If you only get one answer, you don't need to check for extraneous solutions. You only need to check for extraneous solutions if you get 2 answers, which is going to happen in a little bit. Not yet. Number 2. The big thing to remember in number 2 is you cannot multiply the -2 and the 6 together because the 6 is stuck under the radical. So how do we get rid of that -2 in front of the radical? We divide both sides by -2. Okay, so this gives us the square root of 6x equals 8. And try not to be lazy with your radical signs. If 6x is supposed to be under the radical, make sure your radical extends all the way over 6x. Okay, this is a square root. How do we undo a square root? Square it. So 6x equals 64. Are we done? No, now we need to finish solving by dividing by 6. So it's approximately 10.7. If for some reason I use the directions, leave your answers as exact or leave your answers as simplified fractions, you could simplify this fraction and leave it as 32/3, but usually rounding is fine. All right, next page. Your first step is to isolate the radical. What do you think we should do first? Subtract 5. Now, question. Can we add 7 right now? We cannot add 7 right now because -7 is stuck under the radical. You can't do anything to the stuff under the radical until the radical is gone. So our first step is to subtract 5 on both sides. So we have the square root of 4x minus 7. Again, don't be lazy. If your radical is supposed to have 4x minus 7 underneath it, make sure your radical extends all the way over 4x minus 7. If you get lazy with your radicals, you are going to forget what is under the radical and what is not, and you're going to make mistakes. Okay, to get rid of that radical, what type of radical is that one? It's a square root, so we need to square both sides. Now, this one's pretty obvious. What is -3 squared? +9. But say it was a number that you didn't know off the top of your head. If you punch -3 squared into your calculator is going to tell you the answer is -9. Is that correct? No. When you square something, you're multiplying it times itself, so it must be positive. If you enter it into the calculator with those parentheses like I wrote it, then your calculator will compute it properly. And it is because of PEMDAS. What your calculator is doing is squaring before it tacks the negative on. It considers that negative to be like multiplication instead of part of the number that you're squaring. So whenever you're squaring something that's negative, just take a moment and think and be smarter than your calculator. Now to finish solving this, we would add 7 on both sides. So 4x equals 16. And then divide by 4 to get x equals 4. Okay, we aren't actually going to do number 4, but I want to make a special note. What is the index in number 4? A fourth root. So once you get the fourth root of 2x isolated on one side of the equation, what do you need to raise both sides? What power do you need to raise both sides to? To the fourth. So don't forget, if the index is 4, you're raising it to the fourth. If the index is 2, you're raising it to the second. If the index is 3, you're raising it to the third. Give me a nod if you understand that. I'd be really interested to see if the people watching the video are nodding right now. Okay? All right. Let's look at number 5. Is the radical by itself? On the right side, the radical is by itself. So to get rid of that radical, we need to square both sides. And I'm going to leave my original problem kind of alone. So I might not be showing all of my work, but I think you guys will be able to follow. So I squared the left side, and when I squared the square root, the square and the square root cancel each other out, so I have just the 2x plus 28. Okay, this is the part that you really need to pay attention to. You cannot simply do x squared plus 2 squared. It doesn't work that way. What does squaring something actually mean? Multiplying it by itself. So this means that this is x plus 2 times x plus 2 equals 2x plus 28. We need to multiply this out. Technically, the term is expand. We need to expand this. We need to multiply it out. FOIL, double distribute, whatever you call it. Now you can double distribute. X times x, x times 2, 2 times x, 2 times 2, combine your like terms, or use the factoring trick backwards. The first term is x squared. The middle term, you add those two numbers together. What is 2 plus 2? So our middle term is 4x. The last term, multiply those two numbers together. 2 times 2 is 4. Now, we need to solve this equation. The problem is, we have both x squared and x in this equation. So it's not as simple as just getting your x's on one side, getting your numbers on the other. When you have x squared and x in the same equation, you need to get one side equal to 0 and factor and solve. So let's get one side equal to 0. I'm going to subtract 2x on both sides and subtract 28 on both sides. To factor this type of problem, it factors into two binomials. Because it's x squared, the first part of each binomial is going to be x, because x times x would give us that x squared. In these blanks, we need to figure out what numbers would multiply to give us negative 24 and add to positive 2. And if you need to write blank times blank equals negative 24, blank plus blank equals 2, do that. If that visually helps you, do that. So let's see, 24. 2 times 12, no. 3 times 8, no. 4 and 6, it'd be negative 4 and positive 6. So minus 4 and plus 6. Now that is the factored form. Multiply these things together, the answer is 0. Now we need to figure out what x values would make each of those parentheses equal to 0. If the factor is x minus 4, the solution is positive 4. If the factor is positive 6, the solution is negative 6. For those of you listening on the video, that's because 4 minus 4 would give you 0. Negative 6 plus 6 would give you 0. You're looking for the x value that would make each set of parentheses equal to 0. Okay, remember what I said earlier? You don't have to check for extraneous solutions unless you get 2 solutions. We just got 2 solutions, so we need to check for extraneous solutions. So let's plug each of these answers in to the original problem. You're going all the way back up to the original. Don't go to the blue line. Don't go to the green line. Go to the original problem. So let's plug in 4. What is 4 plus 2? 6. So we plugged in 4 on the left and we got 6. Now plug in 4 on the right side. 2 times 4 is 8. 8 plus 28 is 36. So 6 equals the square root of 36. Is that a true statement? Yes, that solution works. Now let's plug in negative 6 and see what happens. What is negative 6 plus 2? Negative 4. What is 2 times negative 6? Negative 12. Negative 12 plus 28? 16. Is the square root of 16 equal to negative 4? Okay, pause. This is where I want to wring math's neck, because this is a really strange rule. If the square root is given to you in the problem, you must assume the positive root only. So this square root was given to us in the original problem. That means this square root must equal a positive number. So the square root of 16 equaling negative 4 doesn't work. That makes this an extraneous solution that we cross off. So again, the rule is, if the square root is given to you in the problem originally, you must assume the positive root. If you put the square root in the process of solving, if you've got x squared and you square root both sides, you have to put a plus minus in there because you don't know if it's the positive or negative root. But if they give you the square root, you must assume a positive answer only. Give me a nod if that makes, if you at least can accept that. Okay. All right, let's change number 6. Number 6 is going to be x minus 3 equals the square root of 4x. I would like you to follow the pattern that we did in number 5. Try number 6 on your own. We're going to skip 7 and 8, by the way. Step 1, square both sides. Step 2, expand that into x minus 3 times x minus 3. Multiply that out to get your trinomial. Step 3, you have to get one side equal to 0 before you factor and solve. So get one side equal to 0. Step 4, factor. You're looking for the two numbers that multiply to give you 9 and add to negative 10. That would be negative 1 and negative 9. Then solve. X is 1 and x is 9. Step 6, check those solutions. So if I plug in 1, 1 minus 3 is negative 2. 4 times 1 is 4. So I'd have the square root of 4 equals negative 2. According to that rule, if the square root is given to you in the original problem, you must assume the positive root only. So that is an extraneous solution. Now let's check 9. 9 minus 3 is 6. 4 times 9 is 36. So the square root of 36 equals 6. That works. So our solution is x equals 9. The important thing here is that you're checking this back in the original problem before you did anything to it.